All right. So this is going to be our agenda for today. Let me click this slide. So our class, we have totally 20 classes. Okay. So today is class 1. That is Introduction to Data Analytics and Visualization. Today's class is basically going to be a theoretical part class only. Okay. You don't have to take any notes or something. So I'll be sharing this presentation to you all in Google Classroom, and the class recording will be there. Okay. So if you just sit and watch, that should be okay for today. So just the theoretical part. Okay. So no hands-on work today. So let's get into the schedule. So this is going to be our schedule for the whole program. Let me do this. I'm going to hide this floating meeting control. All right. So we meet every Mondays and Wednesdays, 5 to 7, and we are here in class 1 today. Okay. Intro to data analytics and data visualization.
Great. I don't know. It's blurry.
So class 2, that is Wednesday, we'll be looking into data collection and cleaning. So basically the first two class will be common for both Excel part and Tableau part. Okay. So when you get into the class 3, we'll be looking into Microsoft Excel. So some intermediate level. Okay. So here we have mix and batch of students level. So some attended level 1, they did not join level 2. Some did not attend level 1 and 2, just joined level 3, right? So no worries. So again, we are going to revisit some concept with Microsoft Excel again based on the intermediate skills. Okay. So that will be just only one class. And then we'll be dealing with data construction and standardization. And then class 5 will be some advanced topic in Excel, basically like pivot table and how to create the dashboard and how to visualize the data. So that will be in the advanced topic. Okay. Then when we talk about data analytics, it's all about statistics, right? So we look into some basic statistics like what is mean, median, mode, standard deviation, spread, and skew. So these terms we might have come across in our school mathematics, right? So that will be like, again, we'll be dealing how we are going to work that in Excel. If we have a set of data, how to calculate median from that set of data. What is range? So those concepts will deal in class 6. And then we don't have the class on the April 14th and April 16th. Then we'll get into analysis methods like linear regression. And then we will look into the project planning and design. Finally, we'll do one project based on what we discussed in Microsoft Excel data analysis and visualization. So you'll be presenting the project on class 10. So once you present the project, if you want, we can record the one that you are presenting and we can give that clip to you. Okay, so you can have that and then once we get into the career readiness level, you can add that in your portfolio. And then we'll get into the Tableau part. So Tableau is again data visualization software. You can also call that as a business intelligence software. So that is very good in market right now. And it is a freely available public software. So we will use that for our data analytics and visualization purpose. So we'll be dealing class 11, Introduction to Tableau, and then Tableau worksheet, and what is groups, bins, and calculation in Tableau, and how to create dashboards, and how to create stories in Tableau, and how to present that. So basically 4 classes will do that. And then 5th class, that is class 15, will be final project collaboration. And then you'll be starting doing project work on Tableau. Okay, you have enough time for the Tableau project because you'll be presenting that only on class 20. Okay, that is a finale project presentation. So what we are going to do after this, we have 4 classes, 1, 2, 3, 4. We will dedicate the time for career readiness, right? So already everyone having the resume. So how we can update our resume based on the data analytic job search, and how we can create a portfolio for us based on the project that we are working. Uh, so how we can prepare for technical interviews, behavioral interviews, and how we can create a networking kind of thing, right? So all sort of things we'll be doing, covering from class 16 to 19. Meantime, you'll be keep on working on your project Tableau, and then finally you will be presenting that, right? So this is going to be our schedule. So 2 weeks, 2 days we meet in a week, Mondays and Wednesdays from 5 to 7 online class. So no class on this week and no class on May 26th and 28th. So for now, what we need is, it is enough if you have Microsoft Excel in your computer for now. Don't worry about the Tableau part until we get into that, okay? So if you have Microsoft Office 365 subscription, that is well and good. Oh no, son, I have only 2016 Excel or 2019 Excel. That's totally good, okay? So we can still manage with that. And good that everyone joined the Google Classroom, so that immediately you will receive the PowerPoint presentation and the class recording next day of our program, okay? So today we have the class, so tomorrow I will post that. All right. So what is the learning objective for today? So we'll discuss what is data science. Okay. So data science is a broad topic, and that data science based on the job performance or the role each one is doing, right? So we can categorize the data science into three categories. We can classify it into more categories, but broadly three: data analyst, data engineer, and data scientist. So we will discuss that. Okay. So what comes under data science? So this program is for data analytics class. So we are going to discuss that. What is a data analytics? So what is a job or a role that a data analyst will do? How typically a day in a life of a data analyst will be? So we'll discuss that. Then we'll talk about ODI model. What is this ODI model? It's called as organizational data intelligence. So as a data analyst, how we take the raw data and then how we convert that to the meaningful information, how we get some insights out of that data. So we follow a model. That model is called as ODI model, organizational data intelligence model. And then what is DRIP organization, which means data rich and information poor. So we talk about that today as a learning objectives. And what is the difference between infographics versus data visualization? When we want to go for the infographics and when we want to go for the data visualization. What is the difference between these two? And then what is fact and what is a fiction? As a data analyst, we always look for a fact. Okay, so we'll try to clearly distinguish between what is a fact and what is a fiction. So this is going to be our learning objective today. All right, let's begin with the data science. As I said, under the umbrella of data science, there are various broad categories. Okay, three main category is data analyst. Based on the job role they are performing, they are called as data analyst. Based on the job role they are performing, they are called as data engineers. And here, data scientists. Basically, the role of a data analyst will be, once they get the raw data, right? So their object is to collect the data and clean the data and organize the data. Mostly data analysts will involve in descriptive analysis. So what is descriptive analysis? We have a data, and then what's going on in that data? What information will we can get from the data? So what is the trend from the data? So that is description. We describe the data of the past. For the year 2024, we have this data from the company sale. So what went well, what went wrong, right? So we are going to describe that. We are going to analyze that from the past data that is descriptive. And there are other analysis method, which is diagnostic analysis, predictive analysis, and prescriptive analysis. So based on the role, each will take those analysis part. But strictly speaking, data analyst will be involved in descriptive statistical analysis. So they create visualization dashboard, which help the company to interpret those data and make decisions out of that data. And then data analysts help to present the results to technical persons as well as non-technical person and business or any stakeholders. So that is the role of the responsibility of data analyst. Now, who is a data engineer? What his role will be in a company? This data engineer will act as a bridge between the data analyst and data scientist. Data engineer build or optimize the system that allow data scientists and analysts to perform their work. Their job is to make the data ready. So that is what they will do. In short, you can see here, the data engineer ensures that any data is properly received, stored, and that is accessible to other user. Other user in the sense, data analyst as well as data scientist. So that is what the data engineer's primary role. Whereas data scientist, still data scientists will do all sort of data analyst's job, but they will try to do some more expertise skill in doing the machine learning model and some advanced statistics and using some programming language. So they will be mostly involved in predicting the things. As I said, data analyst is mainly of the past data, analyzing the past data. Data scientists are futuristic. So they predict things, they forecast things, and they will do real-time analysis. If I want to give an example, let's say that we are doing a bank transaction, okay? So we are having a credit card. Let's say Andrea is having a credit card from a particular bank. She always used that credit card in Rhode Island, in and around Rhode Island. And she went for a family trip to, let's say, Florida. There she uses her credit card. So what happens now? The zip code differs. Usually this is not the pattern, right? Usually this particular person used the credit card only in Rhode Island zip code. Suddenly it triggers from Florida. What will happen? The system will monitor that and immediately try to block the transaction or send the alert message to Andrea. So that is real-time monitoring and prevention. So that type of thing is what comes with data scientist. Current data, current transaction, and the future, right? So that is data scientist. So data analyst collect the data from the past, analyze, provide the report, and then tell what needs to be done, what corrective measures needs to be taken. So that is data analyst. All right. So analyst, engineer, scientist. Definitely a data analyst can move to the data engineer role and learn more learning languages and some programming concepts. Definitely they can also look into data scientist job in future. But this will be the starting point. Now, what is data analytics? We all know drawing insights from raw information and then finding the trend patterns from the data and correlation. What is correlation? Is there any change with one value with respect to another value? That is correlation. Relating something, okay? Relating, correlation. So just see this one, relation. Is there any relation with one data over another data? For example, let's say that we have x-axis graph and then we have y-axis graph. In the x-axis, we are measuring the temperature, outside temperature of the sun. Okay. If the temperature is too hot, right? If the temperature is too high, in y-axis, what is the sale of the ice cream? Too much hot, the sale is more. So one data correlates to another data, that is correlation. Correct? A student studying more hour for the exam, getting higher score. So that is correlation. Is there any correlation in this too? So that is correlation. So these insights that used to optimize the process or increase the overall efficiency of the system comes under the data analytics concept. The person who do all this is called as a data analyst. All right, so let's watch this video, how a typical day of a data analyst would be, right? So for this, I'm going to pause the recording for a while. All right, so you can watch from this video, right? Data analytics is a common for all the domain, correct? It can be applied for healthcare, it can be applied for retail industry, banking, finance, education. Yes, various sectors we can apply. So data analytics is a common field that can be employed to various sectors. So the next learning objective is organizational data intelligence model. Okay, what is ODI? Every industry follows their own pattern. Microsoft follows their own ODI model. Google follows its own ODI model. IBM follows its own ODI model. But what we are going to discuss in our class is suitable for all sort of industry. Okay. So we start with a question, whatever the data that we want to analyze. Okay. So always we start with a question. To answer that question, we collect the data. So we clean the data and then we visualize the data and then analyze and interpret and then take action. And then the process continues. So the data analytics is a cyclic process. You can see here, it is a cyclic process. Linear means it just go and never come back. That is linear process. Cyclic process is again and again, you refine the system, you fine tune the system, make perfection. And sometimes we have to go back and forth here. You can see the arrow double headed here, right? So once we visualize the data, we will see, oh, we have not cleaned this data. Again, we go back and then improvise the data and then come back. Same thing here too. Once we visualize the data, when we get into analyze phase, we will feel that, oh, okay, we should have visualized that in a much more different graph rather than bar chart. We should have go with another chart like that, right? So we go back and forth. So it is cyclic as well as back and forth repetitive, right? And then throughout this entire cyclic process, we need to maintain the integrity. What is data integrity? So the data should not be altered. In the name of data cleaning, we should not just remove the data, right? So we have to maintain the integrity of the data throughout the process. In short, you can remember this phrase called as GIGO, G-I-G-O. G-I-G-O. What is GIGO? Garbage in, garbage out. If our data is like a garbage, okay, and we feed that into the system, the output will be garbage. That's what technically they used to say GIGO, garbage in, garbage out. So our data should be very clean to have a perfect analysis. To clean the data, we use various software. In this class, we are going to use Microsoft Excel, right? And then to visualize the data, there are multiple softwares available in the market. We'll be using Microsoft Excel and then Tableau. to do that. All right. So our data intelligence models start with posing a question and then collect and clean the data, visualize the data, analyze the data, and then take action. And then if required, repeat the cycle. Throughout the process, we maintain the data integrity. All right. So now first we'll take the first one, pose a question. Before we begin the analysis process, we must consider what problem we are trying to solve. We should have a question. Say, for example, how do we expand our customer base? Let's say this is my question. So based on this question, I have to collect this data. So where is my current customer base located? How much customers I have? How I can improve my customer base? So those analysis I can do with starting with a simple question. Let's say that I have a question. I want to see in Rhode Island, which occupation category will find easiest time in getting the job. Either it is a healthcare industry or a education industry or a retail or business, finance. I want to do the analysis. I want to get some data out of that. So this is my question, right? So for this question, where I will get the data? Definitely trusted source, right? We can go with the government website. So DLT, Department of Labor and Training. So they have all the data, how many jobs are being posted and how many people are applied for the job and still how many vacancy are there. So we have the data there. So we will get the data and we'll try to answer this question. We'll do that in Wednesday's class. Okay. So this is the question. Which occupational category will find easiest time? Okay. We'll get the job very easily. So that is one question. So for that, we are going to collect the data. And then once we collect the data, we'll analyze that and we'll get the output and we'll find the decision. Okay, this category has a good time finding job in Rhode Island. Right? Now, collection. How we collect the data? Basically, data collection method involves two. One is primary data collection. Another method is secondary data collection. In primary data collection, there are two methods. One is survey method and other one is observation. So what is a survey method? We survey what the question we have. We can go with the Qualtrics kind of software or we can go with the Google form. We create that and then we send that link and then we get the survey. We have the data. We collected the data. So doing that is primary data collection. Okay, primary data collection. This observation. Let's say that as a scientist, I'm as a botanist, I'm observing the growth of the plant. This week, this plant has grown this much centimeters, this much inch. Next week, I'm measuring the height of the plant. Another week, the height of the plant. Yeah, the growth of the plant from week to week. I'm just observing that and then measuring that. And then how about the person who is doing proper exercise? How is his health? I'm monitoring that versus the person who don't do proper exercise and don't have good diet and I'm observing that. So this versus this, right? And how about the health or the mental level of the person who do a regular meditation and the person who did not meditate? I get a two individual group. One, I'm saying do meditation and then I'm measuring their outcome. One group, no meditation. I'm just measuring their outcome. This is mere observation. Yeah. And then I'm just going to the busy street and then I'm just observing how many cars are moving a particular brand. Let's say Ford. How many red color Ford are moving? How many white color Ford are moving? How many silver color Ford car are moving? I'm just observing and then recording that information. all the engines and everything is one and the same, right? But I'm seeing more silver car rather than red color car. So what it concludes me? It concludes that the taste and preference of the buying habits of the individual consumer. So that is observation. So these are all the data that how we collect. A primary data collection comes with survey or mere observation. What is the secondary data? Secondary data is the online data or any database. You remember our data engineer? So he prepared the data for us, database. He prepared the data in a SQL server. We can readily make use of that data. So that is secondary data. Or online data. Just now I said I'm interested in finding the job trend in Rhode Island. So where I'm going to DLT website. I'm going to online data. I'm just downloading that. So that is secondary data. Already someone collected using the primary method and then updated for us. I'm just utilizing that data, correct? So that is secondary. Primary data is you just go to the field and do the observation or survey, and then you clean the data and make use of that. So data collection method, primary. Secondary, already the data is available. I'm just using that. My data engineer has prepared the data for me. I'm just requesting the access and then using that. So that is secondary data. All right. So how to pose the question? Once we are ready with the question, where to look for the data? Once we get the data, how to clean the data, right? So this is data collection part. Now we'll see what is the cleaning part. So when comes under the data cleaning part, we all are more or less one and the same information, cleaning, data wrangling, and then ETL. So basic cleaning tools we can do with Google Sheets, like removing the unwanted record. We can do that with even Excel sheet, right? So Google Sheet, Excel sheet, MS Access. And then data wrangling, we can use SQL query tools or software like Alteryx, OpenRefine. And for the ETL tool, we can use scripting like Python, JavaScript, or SAS. These are all the various data cleaning tool. So for our program, we'll be using Microsoft Excel to data cleaning. Okay. And in that Microsoft Excel, we have a Power Query, which is nothing but this ETL tool, ETL. What is this ETL? Extract, transform, and load. That is called ETL. We extract the data and then we transform the data in which we want, and then we load the data. That is called ETL. So we will do that in action. We'll get when we get into the Excel class, we will do with Power Query. So Power Query is all about ETL, extracting the data, transforming the data, and loading the data the way in which we want. Okay, so that is ETL. So data cleaning, wrangling, and ETL helps in data preparation job. Next, we are going to move with the visualization role, right? When we talk about visualization, it is both art as well as science. Okay. So logically, if you do something, we say it's a science. When you get some artistic effect, color, theme, it's art. So there are various softwares available for visualization, business intelligence tool as we call. So Microsoft Excel, Tableau, Power BI, Looker Studio, and there are plenty. Here we have few lists. There are a lot of lists in the market. Okay. So the high listed are the first four, Microsoft, and then Power BI is also from Microsoft. Tableau is from Salesforce. If you are aware of Salesforce, it is a company which have the software for CRM, customer relationship management, CRM software. So they purchased the Tableau, and now Tableau is part of Salesforce. And then Power BI. Looker Studio is from Google. Okay, Google use Looker Studio to visualize the data. So in our class, we'll be using the first two, Excel and Tableau. So we use various methods to analyze the data. Okay, we use regression method, we use statistical significance, and we use affinity market basket. Let me give a simple example for each. What is regression analysis? The linear regression analysis. If the trend is like this, it's a positive trend. If the trend is like this, it's a negative trend. So we'll deal that when we get into that. So as I said, the example, see, for example, in the x-axis, we plot the temperature outside and then sale of the ice cream here. Higher the temperature, more the sale of ice cream. Less temperature, less sale. So relation. So we do the regression analysis, correlate with the two parameters. So we call this as dependent variable and this is independent variable. In other words, this is the cause and this is the effect. Cause, effect. What causes for, say, more sale of ice cream, increase in temperature? So we can go with another example, retail example. The house with more number of bedroom and bathroom, higher the price. The house with less bedroom and bathroom, less price. The house that is built very old, the age of the house, very old, less price. The house that is recently built, higher price, right? So there is a relation between these two. So these are the analysis that we use. So these type of two things analysis comes under the regression analysis. And then what is statistical significance? When you do some hypothesis testing, so we go with this type of model. Let's say we are designing two website A, website B, and we are launching two with different type audience. And we noticed one particular website, customers frequently using that. They like the design, they like the way in which easily they can add things to the cart and they can buy the items. So let's say that design, comparing to design A, design B has much influence with the customer. Usually that will be measured with the value called p-value. We will get into that these details later, okay? Just for now, theory part. There is thing called p-value. If that p-value is less than 0.05, which means that is the reality. That is not a random measure. So that is called a statistical significance. So A by B, we go with the B. So this is just the theoretical part. When we look into actual case, we will understand this. Okay, for now, just know something. In the analysis, we have regression, statistical significance. And the third one is affinity. What is affinity market basket? When we buy something, you might have noticed that when you buy something in Amazon or something, when you place the order in a cart, you can see the customers who buy this also bought this together, right? That is affinity. The customer who buys the bread always buy butter. Yeah. So that is one product related to other product. So that is called affinity. So these type of analysis and then promoting that when you place something customer, right? So that is called affinity market. So these are all the various type of analysis that we can do and interpret with the data. And finally, we take the action. So this is the action phase, take action. Let me hide this. So the most rewarding part of the data analyst journey is turning the raw data into actionable information. So that is take action. So we completed all the phases. As I said, if you want to go back, we can go back and correct the data and come back to visualize. And then here, if you notice any new thing that we need to analyze and we want to change the visualization, we change that. And finally, with all the findings, we take action. We inform to the particular stakeholder. If there is any new question arises, again, we start the process. And it all begins again. So most often than that, one full cycle of analysis will lead to more in-depth question. So that is, what is this model called? organizational data intelligence model. We start with the question, just remember this cycle, okay? Throughout our class, we'll be doing that. We'll start with the question. Okay, for this question, where we'll look for the data, we'll go there. If the data clean, we'll readily use that, or else we clean the data. Okay, the data is ready. How we want to visualize that? We are going to use Excel or Tableau. We decide that, we visualize that, and then we get the analysis, we interpret the result, and then we present it. Take action. All right. The next one is DRIP organization. So I said data rich, information poor organization, right? Organization rich in data, but lacking the process in produce meaningful information and create a competitive advantage. So that is called DRIP organization. So as a data analyst, we are here to support this kind of organization. The files are stored still in an old format, so not even converted to the Excel spreadsheet format and not properly loaded in the database management system or the BMS system. So as a data analyst, how we are going to help the DRIP organization to take actionable decision, to take some insights, information. So we call this a data lake, right? So all sort of different format are there. We call this as silos. So some data, customer data are still maintained in paper record, not digitalized. And some data, sales data are digitized. And even some transaction data are properly loaded in a database. So like this, there are some organization not properly unified all the data in one system, right? So as a data analyst, we are going to help the organization to get some informed decision, right? So just let you know what is DRP organization. So we have a raw data, and using the raw data, we find some information out of that. Information is knowledge, and finally the wisdom. So we have a data of a sales of a laptop in a particular location. 50 laptop is sold. We get the data, and then we have that information. How we, with that knowledge, how we can increase our sale from 50 to 100. What tactics we can do. So those sort of technique using the data. All right. So what is data visualization? Data visualization is a part of data analytics. As we discussed, it's art as well as science. And one thing what we need to clearly identify is infographics is not data visualization, okay? Infographics is different. Visualization, data visualization is different. So what is the difference? Infographics and data visualization. This is the objective approach and this is a subjective approach. This can be quantified with some information, and mostly when we want to go with infographics and when we want to go with the data visualization depends on the audience. So which audience we want to convey our information. Then we can pick, okay, for this audience, it's good to go with infographics. For this audience, we want to go with the data visualization. You can see here, the left one is infographic, and the one that you are seeing on the right is the data visualization. You can see here, it is a quantified data. See here, let me go back. So this is data visualization that we are seeing the right-hand side. Let's see another example for infographics. So this is one example of infographics from Office of Library Information Services. Still, we have some data, numerical value. This is infographics. Again, this is infographics. Another example for infographics. Let's see some example for data visualization. In 2010, the fossil fuel data was collected and then visualized to show the trend of the top 3 fuel, okay? Top 3 fuel contributors. The fuel are like coal, gas, and oil. Okay, so we have coal, oil, and gas, and then the CO2 emission from 92 to 2010. You can see the countries, United States contribution of the CO2 level of emission, right? See, and then China, United States, China, and then all other countries. So this type of representation, right? This is visualization with a quantifiable data. Now, when we want to go for data, I mean, infographics, and when we want to go for data visualization, as I said, purely the purpose. I want to do some marketing, right? Then definitely I will go with the infographics, marketing materials. I want to produce the result to my management regarding the finance information of the product that is sold for the last year. So I'll go with the data visualization. A general audience, infographics is okay. For technical audience, I can go with the data visualization. All right. So what software or tools I can do? I can use to produce infographics. I can go with Canvas, or I can go with Adobe Illustrator, right? Okay. For data visualization, what software I will use? Now we know Excel, Tableau, Power BI. We can use for data visualization. All right. Okay. Let's do this. We'll do one thing. This is this is 20 minutes video actually. I'm not going to play the full 20 minutes. I will just play a few minutes video. Then we will get a few minutes break and then we'll come back. Okay. Who is Hans Rosling? Okay. Hans Rosling, he born July 27, 1948. He is a Swedish physician and a statistician, public speaker, professor of the Karolinska Institute. And he was a co-founder and chairman of this Gapminder Foundation, data analytics company. And he is the founder of this software. And he has presented various TED Talk shows. Okay, I'm going to play this TED Talk. We'll watch this, and then after this, we'll get a 10 minutes break, and then we'll come back. Okay. For this, I'm going to pause this recording a little bit, and then hide floating meeting controls. All right. Now, question for everyone. If you know the answer, you can type in the chat. Okay. Which month do you think has the most US birthdays? Which month do you think has the US has the most birthdays? It is February, April, Jan. Any guess? December? They collected the data and they have provided the visualization. Okay, I'm going to show that. But before that, any guess? All right. So this is the visualization we have. Now you can tell me from this chart, right? Which birth dates are most common in US? You can see here from July, August, September, you can see most birthdays, right? Or darkly shaded here. If you want to be more specific with the dates, particularly September 8 to 30, right? Most birthdays. So this is one visualization, right? A kind of visual. How they are presenting that? With the color code. Darker the color, higher the birthday babies, right? All right. Which United States have had the strongest tornadoes? Just imagine we have the data, how we can present that to the audience? Statements with the map, correct? Let's see how they are doing. See here, they took the map and then just looking at the map, we can definitely say tornadoes have in the east coast, right? So not in the west coast, the east coast. So they use map to visualize this data. All right. So now everyone has to type in the chat I'm going to display one data grid. In that you have to count how many three are there, how many number three are there. I will display only for few seconds, okay? Within that you have to tell me. Ready? One, two, three. How many threes are there? Count very fast. All right. Anyone counted? No, no one. Just
Only two.
five. Elham said five. Okay, very close. Six. Vinicio. Awesome. All right. So let's see. Now you tell me. Now you count and tell me.
10.
Now you tell me. Did you count it?
Seven.
Seven. Yeah. How you said? How you said
What?
seven? How you said correctly seven? Because what technique they used in this visualization? They increased with the bold and then they increase the size of the number 3 so that it stands from the rest of the data, stands out from the rest of the data. This is one visualization technique. You got that? Formatting, right? With the bold and increasing the number. Okay, let's do this. Now tell me how many 4s are there in this grid. I will give only few seconds, okay? 1, 2, 3. How many 4s are there? Any guess? Okay, okay, let's see. Now you tell me. How many 4s?
Seven.
Seven.
Okay, how it's possible now? So what technique they used in this visualization? Color code, correct?
Yeah.
They highlighted all the 4 with yellow. Automatically our eyes goes with the yellow and then we easily count the 4. So this is one technique, data visualization technique. This is an art, right? We discussed that it is art, right? Art as well as science. Okay. Now, let me hide this. Who will be the first to tell me how many 5s are there in this grid? How many 5s? How many 5?
3, 4, 5.
Okay.
I count 5.
Okay, let's see. Let's see.
5.
Now how many 5s are there?
Oh,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.
11. 11.
11.
Okay, so what technique they used? For each number they have
Yeah.
specified a particular color. For 0 they have given red, for 5 they have given yellow, for 1 they have given green, correct? So these are all some visualization technique. All right. All right, so this we have revisited. All right. So this is one important historical data visualization. An 80-year-old, okay, an 80-year-old, his name is Charles. In 1869, he used the detailed data collected by Napoleon, okay, Napoleon and his army, French army. They try to invade Russia, right? They try to invade the Moscow. So they call that as a true cost of war. Just 1 year, 1812 to 1813. So just imagine in 1869 there is no such a sophisticated software or idea or anything, but see how this Charles has mapped that and attributed all that information. Okay, so that's what we are going to see here. See here, he collected all the data like this. The Napoleon's army when they invaded to Moscow, right? Russia. So in the chart he attributed 6 different dimensions, okay, 6 different dimensions of data. One is geography. On their way they march, that army march, what are the rivers that they encounter, what are the cities, and then the second dimension is army's course, the path they followed, and then direction, and the number of soldiers, how many soldiers went initially, when they return back how many are alive, right? So that is the soldier count. And then temperature, time, you see 1 2 3 4 5 6 dimensions or 6 attributes he has recorded, and he used this sort of map to illustrate that. See here, carte figurative. I think this is some French word which means carte is 6. Okay, 6 figures. See, this gold color or the tan color, right? So this is the starting point of that army that they entered Russia all the way to conquer this, invade this Moscow, right? So they see initially how many numbers are there. You can see here, and then they went on the way. They faced a lot of uh, freezing weather, and then you see the troop has been reduced, and then finally only 10,000 people remained. And then how excellently he has attributed all the information, as I said, right? So geography is there, the count of the soldiers, right, from this much to this much, he attributed that very cleverly. And then the temperature, see here, the freezing temperature, negative temperature, so everything he has attributed. So this is one classical example of that. See, they started with 4,042,000 men, and then when they returned back, only 10,000 remained, right? So the idea is how he crafted this effectively in that period, 1869. All right. So this is another example that I would like to show. The following is an example of how visualizing data helped save a city from a ruin. Okay. Has anyone ever heard of Jon Snow? Anyone know this Jon Snow? No? By any
No?
chance? No? No one knows this Jon Snow? Famous HBO show. No one knows? Game of Thrones. Oh yeah, Vinicio knows. Okay. Vinicio, we are not talking about this Jon Snow, okay? We are going to talk about this Jon Snow. Alright. Who is this Jon Snow? Why we are interested in knowing about him, right? London, 1854. It was a cholera outbreak in a major city called Soho. So what happened? Next 3 days, 127 people on a near Broad Street died. In next week, 3/4 of the residents had fled that area. All right. Everyone thought within 2 weeks 500 people had died, and mortality rate was 12.8 percentage. By the end of the outbreak, 616 people had died. Then dominant theory stated that okay, what everyone start of this cholera is okay, it is a airborne disease, like a bad air, the polluted air, like that everyone thought, right? But John Snow did not agree that. No, 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 there should be something different, not because of polluted air. There is something. I want to visualize that and prove my theory. See here, I want to visualize that and then I want to prove my theory. So he take that. So he collected all the people who died. Okay, he take that record from the municipal department and then he took the chart. So Dr. Snow took a map of the Soho neighborhood and marked each case of the cholera with the black rectangle. See here, one rectangle means one person died, 2% died. Like that, he identified everything with this dot rectangle wherever people died. And then what he did, he then added to the map the location of the source of disease that he had suspected. The source of suspicion, right? So what is the source? Everyone said it is air, polluted air, but he did not believe that. So he want to prove his theory. See here, the water pump. So wherever he noticed huge number of people died, he noticed the water pump was there, right? See, water, drinking water here, here, and here. So he proved that. So there was something issue with the water. So that was the reason for the death. So he analyzed and presented this visualization and he proved his theory. All right. Now it's time to play. As a data analyst, we should always look for the fact rather than fiction. Okay, whenever you hear some statement, we need to find evidence for that. What is the source of that? So that is fact. We should not blindly believe anything. So let's do this. Fact or fiction? Just guess and tell me fact or fiction. While in grad school in 1981, future Vice President Al Gore announced the birth of what would become the internet as we know it today. All right. In a New York Times column, he sets out the specification for the worldwide interconnected web of data accessible to anyone from anywhere. Is this statement fact or fiction? If someone says to you, oh, Olga said this, that means what immediately we will do as a data analyst? Immediately you will believe that, or you will do for some evidence? Yes, we have to go for some evidence. We have to find whether this is a fact or fiction, right? Okay, we go and search for collect some evidence, and then we see no, it is a fiction. Correct? The future Vice President Al Gore did not said that. Who said that instead? In 1991, the computer scientist Tim Berners-Lee announced the birth of what would become the internet as we know it today. So he is the one who said that worldwide interconnected web of data accessible to anyone from anywhere. Said by Tim, not that person, right? So that is a fiction. It's not a fact. So like that you have to verify. That is the idea of this topic. Okay, every time go by the fact and not with the fiction. Okay, let's go with one more example. The earliest discovered mechanical computer was from the 2nd century, circa approximately 100 to 200 AD. Is this fact or fiction? So we should not believe this, right? So we need to find the appropriate data evidence for this. All right, let's say yes, it is a fact. The Antikythera mechanism was produced presumably by Greek scientist. It's a CPU, consists of 30 interlocking bronze gears, and it thought to be have been designed for astrological purpose. Okay, for moving for monitoring the cycle of the moon and astronomy. Of now they moved that for the Olympic Games. It design suggests it is probably an evolution of an earlier device, but this so far remains undiscovered. All right, so this is fact. So this is that machine. Okay, so this is that machine, 30 interlocking bronze gears. So they collected this fact and they said that yeah, that is in evidence, so it's fact. How about this one? Is this a fact or fiction? The earliest example we have of human storing and analyzing data are from Greek. They are telling that it is from Greek, circa 2500 BCE. It is a fiction because the earliest example of human storing and analyzing data use the tally sticks. Okay, so that they said it is from Greek, so that is not correct. That is a fiction. The fact is they used tally sticks, and that was discovered. The Ishango bone was discovered in 1960 in what is now Uganda and is thought to be one of the earliest piece of evidence of prehistoric data storage. All right. The US federal government legally must disclose all federal contracts on a publicly available data portal. So this is the statement that someone is giving to you. You will believe that, or you will do some research to check the fact. Yes, we have to do some research and check whether this statement is correct or not, right? All right. Yes, this is a fact. In fact, the Federal Funding Accountability and Transparency Act of 2006 requires that federal contract, grant, loan, and other financial assistance awards be displayed on a publicly accessible and searchable website to give the American public access to information, right, on how their tax dollars are being spent. So this is fact. Just getting the statement, we should not believe it. Okay, so that is the idea that every data analyst should know. So the point is that Now data is available everywhere on the internet, right? Any person are going and collecting some data and posting in the internet. So what you do, you go and search something, you get the data and you believe that is the real data and you download. As I said, garbage in, garbage out. So look for the correct website. Is it a government website? Is it from academic university? Then trust that website, right? All right, the last one. IBM can trace its origin back to a problem the US Census Bureau had in 1880 trying to crunch the vast amounts of data being collected. So this is one statement. This statement is fact or fiction? It seems to be fact because the US Census Bureau had a problem. It would take 8 years to crunch all the data from 1880 census, and the data generated by the 1890 census would take over 10 years, meaning it would not even be ready to look at until it was outdated. Okay, now in 1881, a young engineer, Hermann Hollerith, produces the Hollerith tabulating machine. Okay, using the punch card system, he reduces 10 years work to 3 months, and the company he found is IBM. So that is fact. So this is that machine, punching machine. All right. So these are all the topics that we covered today theoretically. All theory only. Okay. So what we started our discussion with data science. So we discussed three basic category under data science, like data analyst, data engineer, and data scientist. And we discussed the roles and responsibilities of each personals. So based on the job they are performing, they are identified either as engineer or scientist or analyst, correct? And then we will look into what data analyst job and how a day in a data analyst typically will be. And data analytics is just a common subject. It can be applied to any industry, right? It can be applied to finance, banking, retail, correct? Education department, or even healthcare, correct? So that is a data analytics subject, a common subject. Data analyst always should start with a model called as ODI model. They ask the question. Once the question is ready, look for the data, clean the data, visualize the data, analyze and interpret, and produce the result. That is what we discussed in the organizational data intelligence model. And where we are going to support this, still the organization that are using silos of information in a not unified method. Every department is maintaining each data without a unifying thing. So there we move and unify the data and do some analysis and find some insights. And we also discussed the difference between the infographics and data visualization. When we go for the infographics for the marketing purpose, right? I want to create a marketing flyer. So do you think we need data visualization for that? No, we can go with the infographics, right? We can use software like Adobe, right? For data visualization, we know what software to use. And then finally, we discussed a few examples, whether it is a fact or fiction, correct? All right. So as usual, like level 1 and level 2, we learn through doing a project, okay? So once you complete the Excel data analysis, you submit one project. So you will formulate a research question, right? So that is how you will start data analysis. You formulate one research question and then take the data that is publicly available data set, and then you can download it and then clean the data set using MS Excel, and then using any of the method that we discussed in the class, you can analyze the data, and then you can provide the chart, graph, or pivot table, statistics, regression analysis, and then you can attempt to answer your research question. And finally, you present your data analysis and conclusion to an Excel workbook format as a dashboard. So once you complete that, you will get one digital badge and a digital certificate, and then you can host that in your portfolio and in your LinkedIn profile also. So once this is completed, we move to the data visualization. Again, the same question, pose a question, collect and clean the data, visualize the data in Tableau, and then identify the trend, insights, and correlations, and then finally take actions. So present the project, we'll get a digital badge and certificate for Tableau completion. All right. So every week I will be telling what to do before next class. So next we are meeting this Wednesday, right? So tomorrow no class, Wednesday we are meeting 26th. So the class 2, it is all about data collection and then cleaning. Okay. So no homework. So only just come for the class 2. You'll see how to collect the data and how to clean that. So we'll go with the two public data set. One question that I said, right? Uh, the easiest time to get the job, which category occupation, right? So we go to the DLT website, Department of Labor training website, and we try to download the data and we analyze that and we'll find the answer. Okay. So any guess which occupation will get easy job in Rhode Island? If you say something, that is speculation, right? So we'll find that with exact data point, fact. We collect that from the DLT website. And then we'll go with, if we have time, we'll go with another question like what is the gender ratio, male and female ratio uh, in Rhode Island, particularly in Providence we'll do. Okay. So we want to do this analysis, gender ratio of male and female in Providence. Maybe 2024, we'll take that data. So any idea where we can look for that data? Population, gender, any idea? It should be a authenticated website. Yeah, we'll go with the census data, right? censusdata.gov. We'll go to the website and we'll download the data for Rhode Island, Providence, and we will see if we want to clean the data and we'll graph that and we'll see the gender ratio for that particular city, Providence. All right. So this is what we are going to do in next class. And maybe I will give some homework for this next Wednesday so that if you have time, you can do that and then bring back when I see Monday. Okay. All right. Any questions for me? Let me do one thing. I will stop recording.
I have a question.